Welcome to Tuesday Lunch and Learn. I'm James Shore. Every week we investigate an interesting software development skill, come up with a challenge related to that skill, and solve it live on stream. And this week we're continuing our investigation or our work on creating a microservice without mocks. Specifically, what we're going to be doing this week is look at reliable requests. If you'd like to follow along, you can check out the code from github.com/jamesshore/livestream. Check out this tag 2020-06-16. Your questions and comments are welcome. As always, go ahead and put them in the chat. We'll take some as we go, and there will be time at the end for more questions. Speaking of time, this is a long episode. We're probably going to run a little bit long today. I could have broken it up into two parts, but I really want to finish this up this week and next week. So I expect it to go maybe until about 75 minutes, about a quarter past the hour is my expectation. All right, let's go ahead and get started because we do have a lot of ground to cover. What we're working on is microservices without mocks. Specifically, the request part of this. What we've been doing up until now is building a RaaS, Route 13 as a service. If you've missed previous weeks, then you can find them down here at jamesshore.com/blog/lunchandlearn. But really briefly, what we're building is a little microservice that's going to take requests from the client and encode them using Route 13. That's the little encoding that you see on the internet for spoilers, and then serve it back. And we've got a couple of things here. We've got the Route 13 server, which is the top level application code, and then an infrastructure wrapper around Node.js's HTTP library. We are using Node.js here, but really what I'm showing you is applicable to any mainstream language. And now I said that this is we're doing this without mocks. And why is that? Well, again, we've talked about this in previous weeks, but very briefly, mock-based tests, solitary tests, are fantastic for testing that a unit works in isolation and even that it calls its dependencies. But what it can't check is that it calls the dependencies correctly. It will only check that it calls the dependencies the way the tests say they should be called. That's fine at first, but over time, as your application grows and evolves, your dependencies behavior will change. That is absolutely guaranteed. Some of your dependencies behaviors will change, and your code that depends on those will break. And if you're using mock-based tests, the tests won't fail. They'll break silently. So what we're doing here is we're using sociable tests instead of solitary tests. The technique I've been showing is still a unit test approach. You're still only testing the unit under test, but now that you're testing that it uses its dependencies correctly. So when the behavior of those dependencies changes, the test breaks, and that's really nice. And you can do this with mocks. You can do the same thing using integration tests, but then you have to write your test twice effectively, and they're also slower and more brittle. This approach gives you all the benefits of unit testing. They're fast, they're reliable, and they give you the benefits of the integration test in that they fail when the behavior changes. So that's what we're doing here. We are going to, a challenge for today is to take our Route 13 service, which already has the ability to serve responses, but it's just serving a placeholder. Now we're going to read the request body, encode that request body, and return that response. So the question is, how are we going to do that? Well, while you're thinking about that, I want to remind you that this show is made possible by the fine people who hire me for training and consulting purposes. Generally speaking, organizations, typically I work with smaller organizations, maybe less than 200, 300 people in the development organization. They've got the capability for a lot of business agility, but they might not have the technical capacity yet. And so they bring me in to do training and consulting, either agile engineering practice training like the TDD stuff we're seeing today, or process development work, particularly around how do you have teams work together when you've got multiple teams? Because a really common problem is that you get bottlenecks between teams, and how do you resolve those bottlenecks? So that's what I help people out with. If you would like me to help you out, or if you'd like to join this group of fine people, go ahead and send me an email, jshore@jamesshore.com. You can also visit my website, jamesshore.com, and I'm always happy to receive tweets from anybody for any reason at James Shore. If you'd like me to work with you, just go ahead and contact me. I'm happy to set up a free consultation. All right, let's get back to the challenge. What we are doing is we are going to take a request from the client, we're going to read that request body, and we're going to serve it back out. Now the question is, how are we going to do that? Well, it's pretty similar to what you've seen in previous weeks. And again, you can find those down here, jamesshore.com/blog/lunchandlearn. We're going to start with programming by intention in order to identify what our API is going to be. Then we're going to build a nullable infrastructure wrapper for the components that the external components that we're using. In this case, Node's request object. And then we're going to give ourselves the ability to test that by making nullable and by using configurable responses. Now, in previous weeks, we talked about behavior simulation, and we will be doing a little bit of that. But mostly what we're going to be doing is giving the ability to configure the response, configure the responses. And that's a little confusing. I'm talking about the responses of the request. So we're configuring the request's responses. If that doesn't make sense, it will once we get into it. Again, programming by intention is writing your code as if all the functions that you wanted already existed and using that to sort of figure out what those functions should be. Nullable infrastructure wrappers is taking the third-party code, wrapping it up, and making it so it can be disabled in production. Specifically, what we're going to do in this case is we're going to make a nullable HTTP request. And then the configurable responses. This is the way we have our nullable infrastructure return the values that we want in our tests. We pass in a set of options to the create null factory, and then implement that in our embedded stub. And again, that will become more clear as we do it. Okay, that's what we're going to do. Let's go ahead and get to it. Again, if you would like to follow along, you can find the code here, github.com/jamesshort/livestream. Check out the tag 2020-06-16. After we're all done here, I'll be uploading the finished results as usual with the tag 2020-06-16-end. And now, if you do want to follow along, you'll need a copy of node.js installed. But other than that, everything is in the repo. Just download the repo and it's all vendored in. Run build.sh or just build on Windows, and that will lint the code and run all the tests. If you want to run just the tests that have changed, lint and only lint and test the things that have changed, use build quick. And if you'd like to have the build run automatically whenever you change files, use watch. That will also make a nice little sound when the tests pass or fail. To run the code, use run. Okay, once again, your questions and comments are welcome. Just go ahead and put them in the chat. Let's get started with this. So what we want to do is we want to modify our Route 13 server, which I've got right here. We want to modify this so that instead of returning a placeholder, we actually take the request in and do something with it. So we're going to start with programming by intention. I'm just going to take this and modify it. How do we want this to work? Well, typically in Node, what you do is you get a request. And that request is going to have things like URL, method, and headers. And I think that's pretty clean. That works nicely. We are going to need the URL, the method, and the headers because when we do this, next week, when we do the routing part of this, we're going to be able to say things like if request.url does not equal something, then we're going to return a not found response. And if the request method does not equal post, then we'll return illegal or method not allowed response, or maybe just method not allowed. That's, I think, 401. And then if the request headers content type is not equal to application JSON, then we're going to return bad request. So these are all the sort of routing things that we're going to need to do. We're not doing that this week, but we'll do it next week. And I like the way that works. That's pretty clean and easy. Now for the body, the typical Node.js body, reading a stream in Node.js is kind of a pain. What you have to do is you'd have to say request.onData, and then we get a chunk, and we've got to accumulate that chunk into a variable, etc., etc. That's just not a lot of fun. Uncle Scientist mentions that the error code for method not allowed is 405. Thanks, Uncle Scientist. So rather than doing this, I think this is where our request wrapper can shine a little bit. Rather than doing all of this, I think it would be nice to have the ability to say something like request dot read body async, and just have it read the whole body into a variable. Now that actually is a little bit of a security issue. We're vulnerable to a denial of service because now we're going to be reading this all into a variable in memory, and if it's megabytes or many megabytes, that could be a problem. We could potentially resolve that by putting a maximum size here. However, today we're not going to do that because we don't have time, but we'll probably get into it in a future episode. So that will give us the input to our code. Then we're going to transform it using our ROT13 transform, and that will give us our output. And then we can take that output and we'll return the status of 200 and the body as our output. So that's my intention. That's programming by intention. That's what I think we're going to do here. Of course, this isn't going to work. It isn't implemented yet. But as usual, programming by intention is effectively pseudocode. It's a way of designing the API by seeing what it's like to use it. So now that we've got that figured out, I'm going to go ahead and comment this out for reference. And now we can do it for real. Okay, there's a bunch of things we need to do here. First off, we need to build, or not necessarily first, but one of the things we need to do is build this HTTP request wrapper. But before we do that, we also have the problem or the question of how do we get that in? We need our server to pass it to our request handler. So let's start with that. Let's write that test. So we'll go to our HTTP server. And in case you don't remember, if you didn't see us last week, this server has a bunch of tests around starting and stopping the server. It has a bunch of tests around requests and responses, and it's nullable. So you have a null version that doesn't actually start or stop. In our case, what we want to do is we want the request handler to take the request object. And I'm going to make a new test for that. Let's say that it provides request object to request handler. Now we're going to need an onRequest async that takes a request, and we're going to need the ability to make an assertion on that. Now I can't do an assertion right here, because if I do an assertion here, we programmed our server to be robust. So if it gets an error in the request handler, it just returns a 500. That's oh, and also before I can demonstrate that, I've actually got to run that request handler. So what we're going to see is this test is going to pass even though it's got a failure in the assertion. So we can't have any assertions in our request handler. So instead what we're going to do is we're going to take that request and we're just going to assign it to a variable that we'll set up here. And now after the request handler has been run, we should be able to make an assertion on that. And in this case, I'm just going to assert that it's an instance of what we want, specifically an HTTP request. That's what I've decided to call our request wrapper. We called this HTTP server, so it makes sense to call the request HTTP request. Now this is going to fail. We don't have HTTP request defined. I did make a little, just to speed things up today, I did make a little, I did make the file, but there's nothing in it yet. So there, it says the instance of assertion needs a constructor, but object was given. That's actually not true. It's just a bug in Chai. Undefined is what we're actually getting there. But Chai says object for some reason. Okay, so let's go ahead and open up our HTTP request. You can see there's nothing in here yet. Now, in our server, the way this works, as you may recall from last week, is when we get a request in the server, we call handle request async and we pass it through the function to call. I think what we can do here is also pass through our HTTP request and just have that wrap the node request. And then down here in handle HTTP request, we can take that as a request and we can pass it through to the request handler here. Now this is changing the signature of handle request async, so we're going to need to modify it here in simulate request async, which also uses it. And I'm just going to stub that out for now and pass null through. This won't work because we're trying to call HTTP request.create, and that doesn't exist. Oh, and also we haven't imported it yet, so let's do that first. Yeah, and that's failing. HTTP request.create is not a function. So let's go ahead and create that. And that's going to take a node request, and we'll pass that through. But I'm not going to do anything with it yet. And we'll do our runtime type checking as well. Now, the node request is a type of incoming message or something like that, but we don't have a way of getting a handle onto that. So I'm just going to assert that it's got to be some sort of object. Okay, I think this will work. And it does. So there we go. We've got the ability to pass a request into our request handler. Now, it's not actually doing anything interesting yet, and that's what we need to test next. And we could do that inside of our server test. We could have a whole bunch of tests that say that the URL is passed through, the method is passed through, and so forth. But all of this is kind of ugly. I think it'd be simpler and easier to test that in a dedicated test file for HTTP request and make it easier to find the test as well. So let's go ahead and do that. I pre-created the test file. So let's go ahead and see that run tests. And there we go. Okay. So the first thing we're going to do is have this provide the URL. Now, as usual with infrastructure, the challenge here is just getting the infrastructure tested. We want to test it for real because there's going to be quirks and peculiarities about how the real code works, and we want to document that and understand it and make sure it works for real. So we need to test this for real. But that does make things kind of annoying. Luckily, we're going to need to spawn a server, we're going to need to make a request for that server, and then we're going to need to make assertions about the request wrapper. Luckily, we've already got our HTTP server created, so we can just use that as our server. So I'll create that. Then we'll start the server. And of course, we have to stop the server when we're done. And it's complaining about starting the server because, of course, we have to pass in the port. And we need to provide the request handler, which is on request async. And that will take our HTTP request. Now that's not going to run yet because we're not making any requests for it. Now last time we wrote a function to make requests to the server, and prior to starting today's stream, I went ahead and abstracted that out into a test helper method. So that's called request async. So we'll await that. We'll pass the port through. And now we can see our on request is running, and that's great. Now we've got a problem here, which again is if this assertion fails, it's just going to return back to our server, which has got, which for reasons of robustness is going to return 500. So we're not going to see that assertion fail in our test. So what we can do here is we can actually await a promise. And in our test, we can surround the body with try catch. And if we get an error, we can reject the promise. And that's going to cause the promise here to end up throwing an exception back to our test handler, which will cause the test to fail. We're also going to need to resolve the promise here at the end so it doesn't time out. And this will need to be async. And there we go. There's our assertion. So that's good. Now we can actually do the thing that we want, which is we want to assert that the request URL is equal to my URL. And we'll pass that in here into our request async. And now we're expecting my URL, but we're getting undefined. Perfect. That's what I would expect. And it is calling that URL. We're seeing it right there. So now we need to implement this for real. I think this will be pretty easy. We just need our node request to be available. So let's go ahead and pass that into our constructor. We'll save it off. And then we can return the URL. As usual, when you're testing infrastructure, you spend more time writing the test than the actual code. Although it is easier than it has been because we do have this existing infrastructure we're able to use. Okay, that's the URL. Now we want to do the method. However, we don't want to write this whole mess every time. So I think what we need to do next is we need to factor this out into an abstract method. Now to do that, we're going to have to take this and we're going to have to bring it out of this code, and we're going to need to take this and bring it out of this code. Let's do this first. This is an options, our options. We can just pass that in like that. And if I do that, I can set it up here. This one's a little bit trickier. In order to run this, we actually have to be able to run some arbitrary function. So let's go ahead and do that. Let's define that the arbitrary function is equal to that. And then here, we'll just await that function. But we need to pass the request through. Like that. There we go. So now this bit of code is completely generic. We should be able to factor this out into a method. And let's call that create request async. Okay, let's look at it, see what it looks like. I think I'd like the options to be first so we can have the function block be at the end. So let's go ahead and do that. And this is looking good. This can all go together. Okay, it looks pretty good. Let's take this and put it at the bottom. Because I like my helpers to be at the bottom, not at the top. And now we can inline this. And we can inline this. And there we go. That's nice and compact. I'm happy with that. So now we can do the method. So we'll say that it provides the method. And the method should be post. And we're not getting that. method. Okay, that's failed. Now this is exactly why we want to have tests around this, because the behavior of the infrastructure isn't always what you think it's going to be. And in this case, what's happening is it's normalizing the case of the method to be uppercase. So we're going to want to document that. So let's make it obvious by saying POST and post. There we go. Okay, next the headers. Doing something very similar, except instead we'll pass the headers through. Okay, it's undefined, as expected. Okay, that's failing because of some interesting things here. When we make the request, the node is going to add a couple of things to that request, the connection and the host. And I'm going to go ahead and just pass those in. Okay. And now it's still failing because, again, we've got a case normalization thing going here. So we want to document that. So let's do that. Let's make it super obvious. We've got my header 1 and my header 1, and those both end up being lowercase. There we go. Now there's something else that I know about this sort of code that I've learned just from experience, which is that in JavaScript and actually in most languages, when you're returning an object, you're actually not returning a value. You're returning a reference to the object. And if somebody else changes that reference, everybody who has access to that reference also sees changes, and that can lead to some subtle bugs. So I want to say that that doesn't happen here. I want to say that it has immutable headers. Specifically, if we set up some headers, and then make the request, but one of our pieces of code deletes the header, we still want if we ask for the request headers again, we still want to see that header. We don't want it to delete for everybody because, again, this is a source of really subtle bugs. One of the most common ones is you might do a sort or something like that, and in JavaScript, those sorts are done in place. So it actually changes the code for everybody. Or maybe you're normalizing it and you make things capitalized. It can lead to bugs. So we want these headers to be immutable. But as you can see, well, actually, I forgot the connection and the host. Let's put those in. And we're going to want the header. What you can see is that header is gone because we've deleted it. So we're asking for it again, but it's gone. So what we need to do is have our request make a copy, and that way we won't have the problem of it being changed out from under us. And this is the kind of thing that you get from having an infrastructure wrapper. Is you get the ability to make these little improvements that make your code less bug prone. Okay, next we need to do the body. And the way the request async works, the one that we're calling right here, is it actually will take the body as an array so we can provide multiple chunks. So let's take that, we'll create the request. We'll say that the request read body async should equals chunk 1, chunk 2. That of course won't work. We don't have a read body async. And there we go. Okay, now implementing this is a bit trickier, not that complicated, but now we've got to do the streaming thing in Node. So we're going to say, we're going to wait a new promise. And we'll listen to our request's data. That's going to give us a chunk, and it's going to be called multiple times. And we'll accumulate that into a body variable, which we'll set here to be empty. And then when the incoming request stream is done, we'll get an end event. And now we can resolve the request, or resolve the promise with the body. And that's failing probably because I forgot to return the result. There we go. Now there's a couple of things here that I'm not handling and I don't actually know how to test. If there's an error, we want this to reject. And if I could test that, I would, but I honestly don't know how to force this error to occur. So I'm just going to put it in there and I'll say this handler is not tested. And then the other thing, as I mentioned before, is to prevent denial of service, we'd really want to limit how much data we could get. And we could do that potentially by putting a max value here. But we don't have time for that today. We'll do it some other time. So now we've got the body. This does raise the question, though, because we're actually consuming a stream, what happens when the stream is read twice? We could store the data, the body, in a variable and then return it again, but I like my code to fail fast. And I'm having trouble thinking of why you'd want to call read body twice. And if you were going to call read body twice, you'd probably just store it off yourself. So let's just say, for simplicity, we'll have this code fail fast if body is read twice. Pellet says, they were about to ask that. I've been bit by this so much in J2EE. Are you talking about reading the body twice, Pellet? So again, we'll need to create the request. Yeah, he's talking about reading the body twice. Yeah, and one of the nice things about test-driven development is because it's done so deliberately and you're thinking about each step, you write a test before you write each piece of code, it really causes you to think about the code in a lot of detail. And so I find that I tend to catch these sort of nitpicky things that sort of make the difference between code that kind of works and code that's really reliable. I catch these things a lot more when I'm doing test-driven development. Pellet goes on to say, in our case, we have an audit interceptor that tries to read things to store in logs. But if we do that, then the actual request processing logic fails since the stream is already read. Yeah, so in a situation like that, you might actually want to have the request cache the result. But actually in real production systems, you're not typically going to read a stream into a variable. You're going to just want to read the stream as it comes. So yeah, that's a bit tricky. So let's see, what we're going to do here is we're going to read the body. And then we're going to read it again, and we're going to assert that we throw when this happens. And again, this throws async is not built into Chai. It's just something that I provide in my wrapper of Chai. Chai, of course, is a JavaScript assertion library that we're using. So we're going to say that it can't read body, request body, because it's already been read. That's what we want to have happen. What is actually going to happen? Well, first it's going to fail because I forgot async. And it's just going to hang. So yeah, that's no good. We don't want that. It's hanging because it's not resolving this promise until we get the end of the stream event, but that event has already happened. It's not going to happen again. So what we need to do is we need to check to see if the event is, if the stream's already been read. We can do that by saying this.request dot, what is it again? Readable ended. And we'll throw some error. Looks like no, we need to return reject error. There we go. And let's get that right. And I forgot to do our type checking at the top as well. Okay, there we go. So now we are handling our URL, our method, our headers. We're handling the case when the headers are, make sure the headers are immutable, and we're reading the body. I think that's it. So let's go ahead and check that in. Now that this code is effectively done, we could use it, but we don't have a way of testing it yet. What we need to do is we need to be able to, in our road 13 server test here, we need to be able to say that we're simulating the request with a particular request. So we're going to need to make this request nullable. So let's go ahead and do that next. We're going to be able to create a request when we don't actually have one. So we're going to say that it, say that the null version provides default values. So we'll make a null request, and that is going to fail because we don't have that method. And we'll just say that it doesn't take any parameters for now. And we'll return a new HTTP request. That's going to work, but now we're passing undefined into our this.request, so that's going to cause all kinds of things to break. Let's go ahead and see that happen. Let's start with the URL. We want to have a default value here. Let's say null request URL. And that's going to fail because request is undefined. So what we can do is we can pass in, this is our embedded stub pattern again. We're going to say new null node request. And again, with the way embedded stubs work is you build them only for use by the infrastructure wrapper and just the bare minimum necessary in order to get the infrastructure wrapper to work. So in this case, all I need to do is to set the URL to null request URL. And it's complaining about line 13. Oh. That needs to be here. As usual, these embedded stubs are actually really easy to write. It's a little more complicated in a statically typed language, but still pretty straightforward. The code's not actually any more complicated. It's just messier and it's just more verbose. It's it's very wordy, but other than that, it works just the same. So for our method, we're going to want that to default to, let's say, get. That's going to fail because we don't have it. Now we do. And the headers default to an empty object. And that should actually be deep equal. There we go. And last but not least, the body. And we'll have that default to an empty string. Now this one's going to be a little more interesting because readBody async is actually calling methods on our request. Pellet asks, good question, Pellet. He says, or they say, do you want empty headers or the ones that Node throws in? You know, we could do it that way. And we do want our null to be as real as possible. But I would say that in this case, I don't care about those. Those are handled, those actually come from the client. They're not a property of what Node puts in. So we're actually going to, we want to return what Node would return, which is the real headers provided. So I think if a test wants those headers, which in most cases they won't, they can provide them. Because again, those come from the client, not from Node. So we are accurately simulating the behavior of Node. We're just not accurately simulating the behavior of the client, which I think is okay. But this is the kind of thing that I might change in the future if I found that it led to a bug. But I haven't found that that happens. Okay, so back to readBody async. Now, readBody async is calling request.on, but of course we haven't implemented that. We could implement our own request.on, but probably be simpler just to extend the event emitter, which is the sort of standard Node way of doing this. And now it's complaining because we haven't called super. Okay, and now it's hanging. And that's because our readBody async doesn't resolve its promise until the end event is received. So we need to emit that end event somehow. And how do we know to emit it? Well, actually, if we listen, what we need to do is just emit it when we listen for it. Because again, we're not writing a general purpose request handler. This is not supposed to be real. This is just barely real enough to make our production code work. So let's do that. We'll implement on. It's going to take an event and a function. We'll just call the real one. But then if the event is equal to end, then we will emit the end event. There we go. Now to make this a little more real, I'm going to make this emit the event asynchronously, because there are some subtle bugs that can happen when you write code that should be asynchronous but isn't. Thanks, Holger. Now I could write a test saying that this needed to be asynchronous, but that's a lot of work. So I'm not going to do it. All right, so we're providing the defaults, but that's not enough. In our test, we actually need to be able to say something like, create a null request that has a particular body. So let's go ahead and say that not only does it provide defaults, but it can configure the various things. And this is where the nullable response or the configurable responses comes in. So remember I said there were three things we were doing today. We're doing programming by intention, we're doing nullable infrastructure wrapper, and we're doing configurable responses. The programming by intention, we've already done. The nullable infrastructure wrapper we've just finished. And now what we're going to do is we're going to make it configurable using configurable responses. Uncle Scientist asks, can you create a null request that can generate the error event? Yes, I could. I'm not going to do that today. So I think the reason Uncle Scientist is bringing this up is this code is not tested. I could make this nullable code generate an error, and that might be valuable, a way of testing that this code works. But it would sort of be testing that the fake version works. What I want to know is that this code is correct in production and when using a real request. And that I don't know how to test. So we could do that, Uncle Scientist, and it might be valuable. We don't have time today to do that, but it wouldn't solve the thing I really want to know, which is that I'm handling errors correctly in production. Pellet says, for the sake of example, if there was an issue when calling endhandler before the other ones, would you just leave it as is since your infrastructure code is the only one that could trigger this error and you know nothing else should be doing it? Let's see, I'm not quite getting this. For the sake of example, if there's an issue when calling endhandler before the other ones, since your infrastructure... So I think what Pellet is saying, I'm not entirely sure about this, Pellet, but I think what you're saying is that if we're just emitting the end event when we are asked for the end event, and it's possible, I guess, that we could do these in a different order, and could there potentially be an issue with that? If there was, I guess we'd run into it, but I don't think there is. Pellet goes on to say, I guess more generically, if there are potential issues with your null infrastructure, but you know that it won't be called except for how you were calling it, do I avoid over-engineering the null infrastructure? Yes, I do. This embedded stub, I write for only the code we have. This is not a general purpose request stub. This is a request stub that is built for exactly this code. So it's my responsibility, and that's why I keep it in here, because these two things are really tightly coupled. So I want them next to each other. So when I change this code, I'll generally need to change this code. Usually the test I've written will fail, but it's my responsibility to make sure that they stay in sync. So that's why I'm not worried about the end being called before error data, because it's not being called before error data. I'm just handling what we have. So to get back to the configurable responses, what we want to do is we want to say that the URL can be configured. So that you can configure the URL. Generally, what I do with configurable responses, although you can do this however you like, and it will be different in other languages, but in JavaScript, I tend to make an object like this, because that allows me to make it optional and have optional named parameters. Now I can assert that the request URL is equal to my URL. And I don't think that's what we're going to get. We actually got an error. The function was called with too many arguments, and that's because of this ensure signature. So what we're going to do is we're going to take some options here. We're going to pass them through to our null node request. And I'm actually going to do the type checking down here, because this is where we know what's going on. So we're going to take some options here and default it to an empty array. And we're going to say that it can be either an empty array or it can be an object. And that object can have a URL in it, which is going to default to null request URL. So I'll say that the URL can be undefined or a string. There we go. It's running. It's just giving us the null request URL back. But now I can just use the URL that we're providing. And there we go. So we'll continue to follow that pattern for the other ones. It can configure the method. And we want the method to work just like the real thing. So we're going to say, and normalize this case. Again, because if the behavior of the null is different than the behavior in production, that can result to some subtle bugs. So expect that method to come through. We'll need to set it up here, type check it here, and then pass it through here. And it's working, but we're not normalizing it yet, but that's easy. We'll just say to uppercase. And now for the headers, same thing. Let's go ahead and just grab what we're doing up here. Grab some headers. We're going to create the null request with those headers. Then we're going to assert that the headers have been normalized. It's going to fail. We're not expecting the headers. So we'll pass those through. Do it here, and this should now give us our headers, but they won't be normalized. Good. And then we can normalize them. So the way we're going to do this is we're going to need to get all the entries out of the headers. That will give us name value tuples. We can map those name value tuples to a new tuple, which is going to be, name is going to be 2 lowercase, and the value is going to be exactly what it was. And that's going to be our normalized entries. And then we can return that, turn that back into an object and return it. There we go, easy peasy. So now we configure the headers and normalize the case. Now, let's say that it can configure the body. So very similar. That's going to fail. We'll pass it in here. But this is not just a simple variable, so let's take this a little bit slower. So we're expecting my body, but we're getting an empty string. And that's because up here what we do is in read body async, we listen for data events, put that in a body, and then resolve the body. So for this to work properly, what we need to do is have our null node response emit this data event. We don't need to emit multiple, we can just emit it all at once. So it is pretty straightforward. We'll just emit the data with the body. Like that. Now, again, we want this to be as close to the real thing as possible. And the real thing, when you read the body twice, it's going to throw the exception. So it fails fast when body is read twice, just like real request. So we're going to do that very similar to the way we do it up here. Except we'll have a null request instead of the real request. And we don't care about the body in this case. And we expected an exception, we're not getting it. So what's happening here is that it's coming through, it's saying read body async, it's getting to request.onEnd, and that's emitting an end. So we're just emitting an end event every single time. So what we need to do is trigger this line right here, request.readable ended. We can do that just by setting readable ended to true. And if we're going to do that, we might as well set it to false in the constructor, although it's not strictly necessary because it's undefined and that's a falsy value in JavaScript. And that's how it works. Now, this is actually one of the most complicated embedded stubs that we've made so far. It looks much worse than it is because I've got all this cruft, but the actual code is still fairly straightforward. Again, the complexity of your embedded stub is generally proportional to the complexity of your production code. Doesn't matter how the real thing works because we're not trying to make a copy of the real thing. We're not trying to implement something that works like the real thing. We're only implementing enough to fake it for our production code. And there we go. I think that's done it for our nullable HTTP request. It does the real thing with the URL method body and headers, and then it has the null version, which can be configured with the URL method, headers, and body. Let's go ahead and check that in. As I said, today's episode is going to run a little bit long. We're getting close to the end, but we're not quite done yet. I expect we'll be done about 15 minutes after the hour. So about another 15 minutes or so. So we've got the nullable request. And in our test, what we're going to do is we're going to set up that nullable request in some way. But then we need it to actually be passed through to our production code. We need to be able to simulate a request with that nullable request. And we don't do that yet. So let's come back to our HTTP server and look at the way we simulate requests. What we want to do here is we want to say that we're going to expect there to be a request here. We'll do it just like we did up here. We'll take that request and we'll store it off. And then down here, we can assert that the actual request equals the expected request. Of course, we'll need to make an expected request. That's just going to be an HTTP request.createNull, and we'll pass that through here. So now we're creating the expected request. We're passing it through to simulate request. We're expecting it's going to be coming out here in our request handler. We're storing it into actual request, which is here. And then we're going to assert that that actual request equals the expected request we passed in. But it doesn't. In fact, it's complaining that our server, our simulate request, can't take any arguments. So let's go ahead and take this in here. We'll take a HTTP request. And if we require this to be passed in, that's going to cause a bunch of tests to break because we have other tests that use simulate request. I think we've got two ways we could do this. We could either default the value here, or we could go in and change the tests that are now broken. I think I'm going to go with the default value because generally speaking in simulates and in situations like this, I find it useful to be able to just simulate the request and not care what the value is. So having this provide a default value is occasionally useful. So that's how I'm going to do it. So we'll just say that this can be undefined or the HTTP request. Okay, so now we are successfully passing it in, but we're getting a null passed through to the request handler. That's because here we're passing null through. So we just need to say HTTP request. And there we go. So now our server simulates requests, and when it does, it passes the simulated request through. All right, that is finally enough. So what we've done is, again, we've done our programming by intention here. We've built our nullable node request. We've made it so it can be configured with configurable responses. And then we updated our simulation to work with that. And now we can actually go through and write our real production code. I think we're all set here. So of course, we're going to start with a test. We're going to say, rather than responding to requests with a placeholder, we're going to say it transforms requests. So we'll make our request, which is going to be HTTP request.create null, and it's going to have a body of something. Let's say hello. And we'll pass that through into our simulate request async. We're going to need to define our HTTP request. And now we can change the expected response. We'll get a status of 200, which we're not doing yet. So let's change that here. Content type will still be text plain. We're not going to do the proper response just yet. That's what we're going to do next week. And then the body should be the output. I could type URYYB, which is the route 13 encoding of hello. But to make this test a little more robust, I'm just going to say, give me whatever the route 13 transform of hello is. And that way, if the route 13 code changes for some reason, if its behavior changes, then this test won't break. Again, sometimes I do it this way. I make the test robust against changes, and sometimes I make it so it will fail so I can know when the behavior's changed and broken something I care about. And we need to require logic. Okay, so we're expecting URY by B back out, but we're getting not yet implemented. So now in our production code, we need to implement this for real. So we'll get a request. We'll read the body out of that request. Transform it to our output, and then output that as our body. And let's see, that will need to be a semicolon, and we'll need to require our route 13 logic. And we need to await our read body here. And there we go, test passes. In fact, we don't need this anymore. Actually, let's go ahead and leave that in because that's our programming by intention. It gives us some ideas for next week about how we want the router to work. Okay, test passes. That's all the tests I can think of. That means we're done, I think. And as usual, I mean, generally speaking, when you're doing this sociable testing where you're not using mocks and your code's actually running real code, if the tests pass, the code works. Now, this is a demo, so the demo gods are going to frown on me for saying that. But generally speaking, it works the first time. So let's see what happens. Let's run the server, and then we're going to make a request to port 5000. Let's see, we're going to need to post to port 5000. And we'll just say, and so this is a tool called HTTPie, and it's a nice little way of making a request to servers. And there we go. We're making our request with application JSON and passing through this object's example hello. Now our code doesn't know about application JSON, so it's just taking the whole body and encoding it. And there it is. Works the first time, almost every time. Actually, pretty much every time. It really does work the first time, every time for me. I've been using this approach for years in a real production system. And it's gotten to the point where, yeah, I have a couple of smoke tests just in case. Those smoke tests never fail. And now if the tests pass, I'll make some changes. I'll make big sweeping refactorings that change like the whole guts of the system. I've done this many, many times. Run the test, get the test working, and I deploy. I don't even check it manually. I just deploy. Now, the first time I program something, I will check it manually just to make sure that my assumptions are correct. They understand how I want it to work and what it looks like. But after I've checked it manually once, if the tests keep working, the code still works. And that is something that I love about this sociable test approach. And that's why I use it over the mocks, because you can make these changes and your code just never breaks. And that's so awesome. All right, that brings us to the end. We do have a few minutes for some questions. So if you have some questions, go ahead and put them in the chat. A couple of reminders before I get to those. First off, next week's episode is the final episode of our Microservices Without Mocks series. We're going to be wrapping up, taking our server and actually do proper routing. So we'll read a JSON request, we'll output a JSON response, we'll deal with not found, we'll deal with the illegal method, or method not allowed, we'll deal with bad requests, do all of that code. All the infrastructure is done now, though. So now we're going to be able to see what it's like to do some coding, work with code that's been written with this nullable infrastructure and how easy and convenient it can be to work with. So that's going to be a lot of fun. Don't miss that. Next Tuesday at noon Pacific, same time as this one, and that is June 23rd. I also want to remind you that if you liked what you saw today, I do provide this sort of work, this sort of training as TDD training, other agile engineering training for your, I can do it for your company. Private training like that is always done using your language, your libraries, your framework, often in your actual code base, which is a great way to learn. If you're interested in that, go ahead and send me an email, jshore@jamesshore.com. You can find me on the web, jamesshore.com, or anybody, you're always welcome to tweet me at jamesshore. I love receiving people's tweets. And again, if you contact me about doing private training, I'm happy to have a free conversation with you about what we can do together. All right, let's get to some questions here. Pellet says, do things change when testing infrastructure if you're doing serverless things? I haven't done anything with serverless. Serverless, I think, is an interesting situation because you're so tightly coupled to what the cloud is doing. I think there are some aspects of serverless I would do exactly the same as what you're seeing here, but the actual serverless API is not something that's really in your control. And that's part of the reason I haven't been super excited about serverless. I think it makes a lot of sense if you have very bursty computational loads. But if I just have a web server that's running all the time, I'm going to use, rather than using infrastructure as a service, I'll use a platform as a service like Heroku that just, handles everything in the background for me and gives me all the benefits of serverless without all the complexity of things starting and stopping out from underneath you. So that's my take on it, Pellet. But I'll have to admit, I've never used serverless. I've not had a use case for it. So I'm not really sure when I'd want to. I did work for a company that did some really heavy duty Monte Carlo simulations for the purpose of insurance. They were insurance actuaries and they did Monte Carlo simulations. Serverless would have been perfect for them because very bursty workloads. But for normal web services and microservices, I wouldn't bother. Uncle Scientist says, can most code-based testing be extended to add nullability, or are there pitfalls you've hit doing that? No, actually, it's really quite straightforward to add nullable infrastructure to an existing code base because mock-based testing and sociable tests, they can coexist no problem. You can actually mock a piece of nullable infrastructure. That said, there are some, like Synone and Node.js, there are some testing libraries that don't like mocking Nullable, but that's a very specific case for Node.js, and you can get around it quite easily just by not passing in the real object, passing in the constructor, or using a different mocking framework. But yeah, the two fit side by side. So if you've got a legacy code base and you want to add sociable tests to it or nullable infrastructure to it, you can do it incrementally. You can do just one piece and just test a little bit. All your existing mock-based tests will continue working. So there's a very nice migration path for if you want to use it. And there are cases where nullable infrastructure isn't the best way to test and you want to use mocks instead. And you can do them, as I said, side by side. Works great. Pellet asks, I'm also curious if you're familiar with mutation testing and if you have musings on that. Seems like a better form of coverage, but you're test driving everything, so you internally should have that. Yeah, mutation testing, so for those of you who aren't aware, mutation testing, if I'm thinking what you're thinking of, Pellet, it's a tool. I think one of the tools is called Jester. I don't recall. I don't do a lot of mutation testing, but it's a neat idea. Mutation testing will randomly... Pellet says one of the tools is called Striker. I am not familiar with that one. But what it'll do is it'll randomly change your production code and then run your tests. And if your tests don't fail, then obviously you have a gap. And that's really valuable because simple test code coverage, that line coverage like you get out of most coverage tools, won't actually catch everything. It won't check that every single path is covered. So mutation testing can be a good sanity check to see if your tests are good. Now, if you do test-driven development the way I'm doing it, your tests are going to be really, really thorough. And so mutation testing is kind of overkill. But if you're not sure, go ahead and use mutation testing. Personally, when I'm doing TDD the way I'm doing it, it's so good that the check that I use to see if my tests are good enough is just, are bugs showing up? Does exploratory testing reveal bugs? Does smoke test reveal bugs? Do I see bugs in production? If I don't see bugs in production, I have a lot of confidence in the quality of my tests. The reality is, in my production system, the one I built using this, I get two or three defects per year. And that's not a joke, 2 or 3 defects per year. And they're always because of third parties. Either a third-party library has changed out from under me, or a third-party service has broken something. Just recently, Auth0 changed something where the API that they were using went from eventually consistent to basically never consistent. That threw me off. I had to go fix that. But that's not the kind of things that test-driven development can catch. It's not the kind of thing mutation testing can catch. Basically, if you're not seeing bugs in production, or if you're seeing very few bugs in production, then you don't need to do mutation testing. That said, I think it is a good, valuable tool for checking that. You know, if you've got something that's super critical and you don't want any bugs in test and production at all, mutation testing and exploratory testings are great tools to prevent that from happening, or to validate whether your tests are good enough. Amber A-Star says, can you please elaborate on the holes in testing when using mocks? I'm not 100% clear on how and why those holes exist. Yeah, I'd be happy to talk about that real briefly. But if you go to this link down here, jamesshore.com/lunchandlearn, you'll find a video on there called Testing Without Mocks, and it goes through it in more detail. But basically, when you're using mocks, you're isolating your production code, your unit under test, from its dependency. So rather than calling B, it's calling the mock. So if the behavior of B changes, now the test of A will continue working even though A is broken. And you can see an example of that in the Testing Without Mocks episode. But a really common example is you're just going to change the behavior. Maybe you're throwing an exception now under certain circumstances that you didn't before. A triggers that situation, but because you're not calling the real code, your test never fails. And it's my experience when you're using mock-based tests, you have to have integration tests in addition to the mock-based tests to catch all those things. But invariably, those tests become slow or they're incomplete. So it's the Sociable test is another way of doing it that's super fast and actually checks things all the way through. Zayas Pro says, are you reading the Steve Freeman and Nat Price book? That is a great question. I've got it right here. If you're not familiar with it, Growing Object-Oriented Software Guided by Tests is reported to be a really good book about doing evolutionary design with mock-based testing. I've been wanting to read it for a while. I've recently purchased it, obviously, but I have not read it yet. And the reason is I want to do some sort of event around it. I'm going to live tweet it, or maybe I'll stream about it. I haven't figured that out yet. And I've had a secret project that I'll be revealing in a couple of weeks that's been taking up all of my time. But I would really like to get to this and do it as some sort of thing that I do with the community. So that's what I'm going to get to. All right, that's all the questions I see, and it is about a quarter past the hour, which is when I said we'd stop. So let's go ahead and stop here. Quick reminder, again, our next episode is June 23rd. That's going to be wrapping up our microservices without mocks, and we're going to be looking at doing the routing. Sorry, Pellet, no hints on the secret project. And again, if you'd like to contact me about this sort of training for your company, your teams, go ahead and send me an email, jshore@jamesshore.com. That is it for everybody this time, everybody. Thanks very much for watching, and I will see you all next time.